Hello and welcome back, friends. In today's LaTeX for Scientists episode, we'll be learning how to insert and resize figures, how to show the compiler who's the boss, and then a couple of little cheeky tips at the end to help you with your scientific documents. As always, links and timestamps are in the description. Let me know in the comments below if you have any questions about what's in the video or if there's anything that you're having trouble with. I'll be happy to try and help you out. Step 1. Packages. Nice and easy to start us off. We're going to call the graphicx package, which helps the compiler to handle images without mucking it up. So in our preamble, we type /use package, squigglies, graphicx. And that's the only thing that we need for the basics of figures. In the interest of keeping this video short and sweet, I'm going to go through some of the more advanced figure packages in a different video. So don't forget to subscribe and click the notification bell so that you don't miss that. Step 2. Get your image. If you come over here to the left sidebar, you've got this upload icon. If you click it, you can either navigate to the file or files that you want to upload, drag and drop them from a folder into this window, or link to your files in other websites. Any old image will do for this. I've already got one uploaded to save a bit of time, so you can pause the video here if you want to and upload your own image before you continue. Step 3. Figure environment. Now that we've got our image, we need to create an environment for it to sit in so that the compiler knows what to do with it. Let's go underneath our very first section heading and type /begin, squigglies, figure. If you hit enter immediately, Overleaf will autofill the rest of the figure environment with all the commands that you need. So what do these commands actually do? Let's run through them one by one and find out. First up, we have /centering. By default, images get aligned to the left, so this makes sure that the whole figure environment, including the caption, gets centered on the page or column, which looks really nice if you're writing your dissertation or thesis. Next we have includegraphics, which, you've probably guessed, is what we use to actually insert the image. All you have to do is put the image name inside the squigglies, and usually we put just the file name without the file extension. This is so that if you upload multiple images with the same file name but different file types, the compiler can pick whichever's the most appropriate for the type of document that you're making. After that, we have caption, where your caption text goes inside the squigglies. The compiler will arrange the caption so that it always goes beneath the figure, which is where it traditionally goes in a scientific document. And then finally, we have the label command. Although you don't strictly have to include a label, I recommend that you always have one for every figure. What labeling does is it gives the figure a unique name that we can use to refer to in the text using our trusty old ref command, and then we don't have to worry about boring stuff like keeping track of which figures have what number, and we can just let LaTeX deal with all of that instead. We'll leave the name as it is for now since it's the only image that we've got, but it's a really good idea to use a name that you're going to remember easily. Then we can go to our paragraph here and type something like, as one can see in fig /ref, and then put the name inside the squiggly brackets, and then when we recompile it will give the figure and our reference to it the same number so that the reader can find it easily. So now we've got all of our elements in place, we can recompile, and depending on the dimensions of the image, it could be either teeny weeny or absolutely massive. So let's see what we get. Turns out it's so massive it got yeeted over to page 2 and it still overhangs the page. So I guess that means that step 4 is going to be resizing. So to resize our image, what we want to do is click right here in between the /includegraphics and the opening squiggly bracket, and we're going to insert a set of square brackets in here, and then inside the square brackets we're going to type width equals, because if we're working in portrait mode then the limiting factor is the page width, and then we'll put /text width after the equals. And so now the image is going to get scaled to the width of the text area. Let's recompile that. And we see it's now the same width as the text. If we want it to be smaller, which we often do to make sure that there's enough white space around the picture, or to reduce the page count, which is what we really want it for, then we can put a scaling factor in front of the /text width. I usually use about 75%, so we can put 0.75 here, like this. Then we'll do a quick recompile. Now we can see it's reduced the size by a decent amount, but the picture is still perfectly visible. You might be wondering why you don't also have to specify the height, and that's because by default the compiler will keep the same aspect ratio when you use this method. You can explicitly set the width and height if you want to. For example, if we do width equals 5 centimeters, height equals 6 centimeters, but this can make an absolute mess, so I don't recommend it unless you don't really care how the image looks. So step 5 is going to be positioning. Despite the fact that the image is a much nicer size, we see that it's still stubbornly parked on page 2 and not where we actually put the code. This can be extremely irritating in a paper where you have a lot of figures, because in a scientific document, the figures should appear as close as possible to the text where you're talking about it. The reason why the compiler does this in the first place is because figures are a special type of object in LaTeX known as floats. Why, you might ask? Because the compiler is allowed to float them around where it feels like until it finds a place where it thinks it should go. So that gives us a couple of options. We can either make the figure even tinier and see if that makes LaTeX happy, or we can just give up and let LaTeX do whatever it wants. I'm kidding, that's never an option. Let's try option 1 first and see if that solves our problem. Let's try halving the current size of the figure. And it sort of worked. The image is at least on the front page now, but the compiler's still being a brat and using its own decision-making process to figure out where to put the image. So let's move on to option 2, which is telling the compiler exactly where we want to put it. So right after begin figure, we can sneakily sneak in some square brackets, and then we have up to 4 arguments that we can use to tell the compiler where we think the figure ought to go. We've got H for here, meaning right here where we've put the code. T for top, which means the top of the next available page. B for bottom, which means the bottom of the next available page. Or P for page, which will put the figure on a page by itself. It's a good idea to specify more than one option, just to give the compiler some choices in case there's a really good reason why it can't go where you want it to. If it's still not doing what you want, then bullying is a valid option here. If we put an exclamation mark inside the square brackets with our argument, it'll force the compiler to override its own decision making. Just be prepared that you might get some strange results if there are good reasons why it can't go where you think it should. And that's it for the basics. As promised, let's also go over a couple of things that you might want to know if you're writing a scientific document. List of figures. You usually expect to see a list of figures in a thesis or a dissertation, but luckily this is super easy. Just go to where in your thesis document you want the list of figures to go, usually after the table of contents, and type \list of figures. Short captions. If you're writing your captions properly, they should be enough to describe the figure in detail without the reader having to refer to the body text. But this means that if you have a lot of figures in your document, the list of figures can end up being almost as long as a thesis chapter by itself. To solve this problem, we can add a short caption to our figure. So if we go here, in between \caption and the squiggly brackets, we can insert a set of square brackets to write a shorter caption, which will be shown only in the list of figures. 2-column figures. A lot of scientific articles will use 2-column mode because it looks really nice, and most journal templates will already be in 2-column mode. But if you have to do it yourself, you come up here to the preamble where we declare the document class, and inside these square brackets we put the argument 2-column. Very simple. And we can see that this has turned it into a lovely 2-column document. The only problem is, and you might have spotted this already, is that when you scale an image in 2-column mode, if you use text width, it scales the image according to the width of all of the text on the page, i.e. all of the columns together. So instead, what you want to do is scale it by \column width. So that's the basics of how figures work in LaTeX. In the next video, we're going to be doing either tables or referencing. So let me know in the comments below which one of those you'd prefer. For now, all that's left for me to say is thank you so much for watching, and I'll see you in the next one.